Can I just say, before I introduce the next speaker, that tomorrow at lunchtime in the Legislative Assembly, the ACT's State of the Environment report is going to be tabled. That's a document that's put together by my office and previously Maxine's office. I'd urge you all to have a look at that because it does in fact carry the climate science for the ACT, courtesy of Dr. Sophie Lewis, who is the ACT Scientist of the Year, formerly a DECRA scholar and also formerly an ANU. Please have a look at the report. The other thing I'd just like to say is this about what Mark just had to say, is that just before he came to the podium, we were talking about the first lines in that report, and I've started the foreword by saying that the Australian government has joined, the ACT government has joined many others in declaring a climate emergency. And Mark said to me, emergency is probably not the right word because that suggests we didn't know what we were looking at. And interestingly, the insurance companies that are talking about what they're currently dealing with in this country are talking about catastrophe. Now, what we need in response to that is the message of hope that Mark gave us. We also need to think about the co-benefits that come from acting. The next speaker is Dr. Robert Glazier, and I will read out some of Robert's background because you might not know him as well as you know the other speakers. He's a visiting fellow at the Australian Strategic Policy Institute. He has an accent that suggests he is not an Australian, but he is. He assures me he is. He focuses on climate change and disaster risk. He's previously with the United Nations as the Secretary-General's Special Representative for Disaster Risk Reduction and a member of the Senior Management Group and the Deputy Secretary-General's Climate Principles Group. Robert has more than 30 years' experience as a practitioner, advocate and policymaker in areas of climate change, sustainable development and disaster response. So why would we listen to him? Before joining the UN, he was the Secretary-General of CARE International, one of the world's largest non-governmental humanitarian organisations, so he might know a bit about that as well. And with over 10,000 staff active in some 80 countries, he certainly had a bit to do with the challenges that we currently face. He was also previously the Chief Executive of the Assistant Director General of the Australian Government's Overseas and Aid Program, AusAid, and he serves on boards of many Australian organisations, including WaterAid. Please welcome Robert Earl.
It was 5 minutes of my presentation. Thank you very much. Mark, thank you to the Climate Institute at ANU for convening these really important meetings. I don't know if any of you saw the Four Corners episode last summer. It was on about a week ago or so. There's a really poignant, really powerful moment in that episode, which a police car is driving through a Sunshine Coast town that is engulfed in flames. There are fires on either side of the car. And they receive a call to rescue a 93-year-old man. The car's already full of evacuees, but there's one voice off camera from the back of the car who says to the driver, "Mate, you put him in, I'll get out." So that's a pretty powerful, moving comment said in a very matter-of-fact way by an Australian taking care of another Australian, a fellow Australian. It's, I'm sure, not unique in the summer of disasters we've experienced here in Australia. I'm sure there are many other examples of that. I think with climate change, which is magnifying bushfires and other hazard risks, we have to absolutely make sure that that image of this lone patrol car with its really dedicated professionals, under-equipped in overwhelming conditions, and presented with a really grim choice of who to save, doesn't become the metaphor for our future in Australia. And for that not to happen, there are two things that need to happen. One is mitigation of climate change, and the other is adaptation, which is what I'd like to talk about right now. What I'd like to do is spend a very small amount of time on the climate science because Mark has gone into that, but I want to highlight a few issues, mostly drawing on IPCC reports. Then I'd like to explain why, as dire as what the science tells us the impacts will be, it is probably almost certainly actually an understatement of the actual impacts. Partly because the science has difficulty describing and anticipating both compound hazards and how they create cascading impacts in society. And then finally, I'd like to give some examples, some illustrations from here in Australia of some of those compound events and cascading impacts, and then some suggestions on how we need to respond on the adaptation front. So first, on the science of climate change. Mark's already highlighted how difficult it will be, first of all, to keep temperatures at only, temperature rises at only 1.5 degrees of warming. And in fact, if you look at the takeaways, when I look at the IPCC report on the, for example, 1.5 degrees of warming that some of you may have read, the real takeaway is that we're going to be very hard-pressed to keep temperatures to 1.5 degrees, that it would take unprecedented changes in society. And in fact, given the inertia in the climate system, if we stopped all greenhouse gas emissions tomorrow, the climate, because of the inertia, would continue warming pretty close to the 1.5 degrees. And as Mark said, emissions are still going up, although I saw a report today that we may have plateaued this year anyway. So that's the key worry, that it looks to me as though we're committed to 1.5, probably 2 degrees, avoiding 2 degrees of warming, which is the upper limit in the Paris Agreement, is going to be extremely challenging. And achieving that, even the 2 degrees, will be extraordinarily difficult. And that, as Mark said, if countries do not increase their ambition to reduce emissions, then we're on track for 3 or more degrees. So that's the first bit of science, just to summarize, actually. The second is this question of what's the difference between 1.5 and 2 degrees, or between 2 and 3 for that matter. And there's an IPCC report that focuses on answering that question. And you would think that 0.5 degrees doesn't make a big difference, but what that report concluded, and I'll just share some of these facts with you, that would result, that difference between 1.5 and 2 degrees would result in a 50% increase in the proportion of the global population experiencing water stress, expose 420 million more people to more frequent extreme heat waves, expose from 180 to 270 million more people to increasing water scarcity, cause a tenfold increase from 8 to 80 million in the number of vulnerable people negatively affected by changes to crop yields. We're seeing this in Australia already, as Mark pointed out. And jumping to a 50-fold increase when you go to 3% or 3 degrees of warming. And all of these factors combining to push an additional 100 million people into poverty. So it looks as though we're committed to 1.5 degrees, possibly 2, without really unprecedented action. But you can tell from the scale of those impacts that the changes are not happening linearly, they're happening non-linearly. And in the case of maybe collapse of ecosystems like coral reefs, even exponentially, potentially. And so we can assume that what we've seen in terms of the changes, even in the last 10 years, will be occurring at the same pace in the next 10 years. And this enormous sense of urgency because there's so little time to prevent this warming and these impacts from appearing. As dire as those projections are, they almost certainly underestimate the actual impact climate change will have on human systems. And that's because most of the research, including the research the IPCC is relying on, actually necessarily treats climate hazards in a way as independent variables, often, not all of it, of course, as independent variables rather than in the wider context in which they're interacting with other climate hazards and with the human system. And let me give you some examples. They might focus on the impact of rising temperatures on agriculture, but not on the compounding impacts of other hazards, flooding, drought, fires, increased pests, saltwater inundation, cyclones, migration of people that are triggered by these other things. These things that will likely be occurring simultaneously in the systemic change that is climate change. analytically extremely difficult to take account of how hazards can trigger other hazards, their interactions, and their links to cascading impacts and responses in human systems. But it's very important for us to get a handle on this, and there's some very good recent work underway now to do this, because it's quite likely that those cascading impacts will be greater than, or be more intense, more severe than the proximate impacts. Now, climate change is increasing the likelihood of these compound events and cascading impacts for, I would say, 4 very interrelated issues, at least 4, I'm sure there are others. The first is it's increasing the severity of many sudden onset hazards like cyclones, floods, and bushfires. With respect to floods, for example, warm air holds more moisture. The data you provided, Mark, was really interesting. I really want to look at that a little more closely, but generally holds more moisture and so increases the prospect of more extreme rainfall. Look at Hurricane Harvey, which in a short time dumped about 1,200 millimeters, something like 127 billion tons of water on the US Gulf of Mexico states, sort of indicative of the scale of this challenge that we have. And the cascading impacts from those record rains were truly enormous. The floods impeded evacuations, caused power outages, spread dangerous pathogens from overrun wastewater treatment plants, shut down 1/4 of US oil production in the Gulf of Mexico, and petrol prices rose as a result. So the severity is one reason. The second is that climate change is increasing the frequency of many sudden onset hazards. And as the frequency of these hazards increase, the likelihood of them striking simultaneously or in closer succession will grow, as will opportunities for cascading impacts. There's already natural variability in the climate, like the ENSO and Niño La Niña, where you have simultaneous hazards striking in different extreme weather in different parts of the world. And as I think Mark pointed out, scientists estimate that the El Niño effect, El Niños will double perhaps at 1.5 degrees, which is a temperature rise we could reach by the 2030s. So the frequency of these events is increasing. The third is that climate change is altering other aspects of the patterns of these hazards, of these occurrence of extreme events. For example, shifting tropical cyclones into new areas of eastern Australia where many of the structures were not built to withstand extreme winds, or lengthening the bushfire seasons, or causing severe flooding in unprecedented locations. More than half of the homes that were destroyed, damaged and destroyed from Hurricane Harvey's flooding were outside of the 500-year floodplain. Fourth, climate change is increasing the slow onset hazards that can greatly magnify the sudden impact hazards. So the combination of the fact that temperatures are rising, which itself, of course, is causing probably more loss of life in Australia than all the other hazards combined to date, or that sea level is rising. These slow onset hazards can greatly magnify sudden onset hazards. A good example is sea level rise, meaning creating more damaging storm surge when cyclones strike, or rising temperatures and drought, not only pushing places that are currently marginally viable for agriculture into chronic crisis, but also making communities more vulnerable to the outbreak of bushfires that the droughts and extreme temperatures are contributing to. So I want to share with you some illustrations from Australia that I think are early indications of these compound events and cascading impacts. And this bushfire season, these horrible disasters we've experienced over the past months are an example of that, where we had an unprecedented drought combined with record temperatures, contributing to more than 11 million hectares of destruction, and cascading impacts that included the hazardous air quality that is still affecting Mark's lungs and others. Actually millions of Australians, in fact, a 75% increase in Australia's annual emissions of greenhouse gases, at least a $4.5 billion blow to Australia's tourism industry, the huge impacts on Australia's biodiversity, to name a few, and the cascading impacts could have been much worse. There was a point at which you may recall that the fires threatened the area around Warringamba Dam, which supplies 80% of Sydney's drinking water. We saw this as well in Queensland beginning in late 2018 and extending into early 2019, when bushfires exacerbated by drought and record-setting extreme temperatures destroyed 1 million hectares of bush and farmland, the largest expanse of Queensland affected by fire since record-keeping began. That was followed very shortly after by Cyclone Owen, which set an Australian record in dumping 681 millimeters of rain in 24 hours, more than Melbourne receives in a year, by the way. It didn't, however, diminish the drought that was affecting Queensland. That happened shortly afterwards, a few weeks afterwards, when the monsoonal trough set in and dumped record-setting rains, flooding over 7,000 square miles of northwest Queensland, killing 500,000 cattle, drought-stressed cattle, drought-stressed and cold cattle. And we saw this as well in Tasmania's summer of 2015-16, in which there were multiple extreme climate events, including the driest season and warmest summer on record, and an intense marine heat wave that contributed to severe bushfires, disrupted agriculture and hydropower generation, caused a disease outbreak in the farmed shellfish industry, and those and other cascading impacts reduced Tasmania's anticipated gross state product by almost 50%. I just recently looked at some figures which are really distressing. Our most recent hazard-prone state is Queensland, and I think it's a harbinger of what lies ahead for all of Australia in a warming climate. It is absolutely remarkable that since 2017, over half of its 77 local governments have experienced 3 or more disasters requiring emergency financial support from federal and state government. Over half of the 77 governments, local governments. So these governments are now in the totally unsustainable situation of chronically recovering from disaster. So what are our options to respond? First, we have to appreciate the scale of the challenge, that this is not going to be a linear change, and our response can't be incremental. We really truly need transformational adaptation. Fortunately, Australia has enormous expertise, science expertise, applied science, in the business community and elsewhere, where it can contribute to major solutions and to this transformation required. I won't spend a lot of time on a lot of items of steps of what we need to do, but I'll just touch on a few. We need to increase our research and understanding compound hazards and their cascading impacts. There's some great work underway, and Pittman, others in Australia, scientists working on this. We need to improve climate modeling to enable policymakers to be able to access more useful climate information in selecting options and policy. Land use planning is arguably the single most important mitigation measure to prevent future disaster losses in areas of new development. So we need to increase our understanding of how climate change is expanding areas of extreme hazard, and we need to take extraordinarily politically difficult decisions not to build in these areas. With respect to our existing development, we're already highly exposed. Over 10% of our GDP and over 2.2 million Australians are in places with high and extreme risk of bushfire. 20% of our national GDP and almost 4 million Australians are in areas with high to extreme risk of tropical cyclone. Federal, state, and local governments may ultimately need to begin coordinating managed retreats from areas of increasingly chronic crisis, with all the social, political, and psychological stresses that will involve. We've actually seen moves in this direction recently in the current drought. New South Wales, for example, is providing skills retraining to the affected farmers to help them transition from farming into new careers. Financial rebuilding assistance will need to shift to buying out properties damaged by floods and other disasters in highly exposed locations, and to subsidizing relocations and land swaps, which will require overcoming major political hurdles, including deeply embedded expectations concerning the primacy of, for example, private property rights. There's some precedent in this. You may recall during Black Saturday, the Victorian government purchased over 100 properties that it deemed were located in areas of unacceptable risk. And finally, and most fundamentally, we have to do everything possible to reduce greenhouse gases as rapidly as possible at global level. This is absolutely, without a doubt, the single most urgent and important disaster risk treatment to ensure that all those other transformational steps we're taking to build our resilience are not overwhelmed by the scale of the hazards and the cascading impacts. This bushfire crisis has not only changed the politics in Australia, and I think it really has and is continuing, but it has also, as was pointed out earlier, affected attitudes globally as a result of the enormous press coverage, and I've seen much of that as well that it received. I know that's cold comfort to our fellow Australians who lost loved ones and who lost properties in these devastating disasters. But if this leads to increased global ambition to reduce greenhouse gases, then the terrible destruction will have contributed to a renewal that enables us to avoid future disasters that will occur otherwise on a much larger scale.